Okay, in this video we are going to talk about special right triangles. There's two types of special right triangles. We have 45, 45, 90 and 30, 60, 90 triangles. In your notebooks you should be able to find a page that looks like this. Go ahead, pull that out, and then we're going to cut out around these edges. Okay, now that we've filled out or cut out our foldable, we need to go ahead and fill it out. And so the big thing when it comes to 45, 45, 90 triangles and 30, 60, 90 triangles is that it's just a ratio. So what happened was, way back a long time ago, these really smart math guys figured out that every time we had a 45, 45, 90 triangle, their sides were in this special ratio to each other. So we know with a 45, 45, 90 triangle that it's an isosceles triangle, and because our two angles are congruent. So I know that these two sides have to be congruent. So they're going to be the same. Whatever this measurement is, this one's going to be the same. That's why they're both x. But these really smart math guys figured out that if I multiply this side length, or one of the legs, by the square root of 2, then I would get the length of my hypotenuse. And in a little while in your notes after this, you're going to go through and use Pythagorean theorem, and you'll kind of see where this came from. But once we figure out this ratio, the problems become so much easier to solve. We don't have to use Pythagorean theorem. So one way that we solve these problems, and the way that I prefer to solve these problems, is to set up this chart. So every time you have one of these problems, we're going to set up this chart. So let me grab a different color. And I've got two practice problems down here on the bottom. So we'll go ahead and we'll set up this chart. You can use the same chart for multiple problems. So I'm just going to set it up. And I'm going to go ahead and put my ratio on the top line so I can keep that in mind as I solve. So I just copied this ratio right here. So the first thing that we need to do, so this 45, that means the x is the side length across from my 45-degree angle. So here's a 45-degree angle, and here's another 45-degree angle in this corner. So the side length that's across from our 45-degree angle would be 5. So that's going to go in our first column. Now we simply just have to finish filling out the chart. Everywhere we see an x up here, we're going to plug in a 5. So I have 5, I have 5, and I have 5 square roots of 2. So this side length right here, x equals 5 square roots of 2. Now that's an exact answer. If we want to find a rounded answer, and some of the questions could be, you know, like you want to find the length of a pole. Well, the length of a pole, we're not going to tell people that it's 5 square roots of 2. So we'd actually just stick that in our calculator. And we would find out that that's approximately 7.1. So x is 7.1 units. Now down here, this problem's a little more complicated. So the side length that we have is actually across from my 90-degree angle. I'm going to switch colors. And our side length is 10. So in my 90 column, I'm going to put 10 here. And now I need to figure out how to go back to this column, these columns here. So one of the ways that we can set this up is this is the same as x square roots of 2 equals 10. Now, when we have a variable next to a number, then that means that they're multiplying, right? So in order to get rid of this and to get x by itself, I need to divide by the square root of 2. Now we don't get a pretty number, right? We don't like having irrational numbers in our denominator. So what we can do now is we can take this and we can multiply this by the square root of 2 over the square root of 2, because this is the same as 1. If you remember, anything divided by itself equals 1. So now when I multiply this across, 10 times the square root of 2 gives me 10 square roots of 2. The square root of 2 times the square root of 2, that's the same as the square root of 4. And the square root of 4 is just 2, right? Now we can reduce this down. Both are divisible by 2. If we divide this by 2, we get 5 square roots of 2. Now 5 square roots of 2, again, that answer is going to be 7.1. So that's funny how that worked out. X is also going to be 7.1 for this problem here. 30, 60, 90 triangles, same idea. We're just dealing with different angles, so our ratio is a little bit different. Our ratio, we take our short leg, which would be across from my 30-degree angle. If I multiply this times 2, I'm going to get the length of my hypotenuse. And if I multiply the short leg times x square roots of 3, I get my long leg. So again, I've got a couple practice problems for us to do here. And let's set up our chart. So our ratio is x to x square roots of 3 to 2x. Now here in this top problem, the 10 is across from my 90-degree angle. So I'm going to put that in this column right here. And so now I need to figure out what x is. Well, something times 2 equals 10. That something would be 5. So our short leg would be 5, and our long leg would be 5 square roots of 3. So x is our short leg, so x will equal 5, and y will equal 5 square roots of 3. Down here in this problem, I made this problem a little more complicated. We have 9. 9 is across from our 60-degree angle, so it's going to go in this column right here. Now again, we're going to have x square roots of 3 equals 9. So I need to divide by the square root of 3. So that again, that's going to leave me with an irrational number in my denominator. So I'm going to come down here and figure out what that is. I'm going to multiply by the square root of 3 over the square root of 3. Then I'm going to get 9 square roots of 3 over the square root of 9. Well, that's going to be actually 3. And then this actually reduces. So it's going to equal 3 square roots of 3. So my x is going to be 3 square roots of 3. Now I'm going to multiply this by 2 in order to get what's across from my 90-degree angle, my hypotenuse. And then I'm just going to multiply the 3 part times 2, the outside part. So I would get 6 square roots of 3. So in this problem down here, x equals 3 square roots of 3 and y equals 6 square roots of 3.